Unit 10, Day 5 notes. Today we're talking about secants, tangents, and angle measures. A secant is a line that intersects a circle at exactly 2 points. So on my circle on the right, it is showing two secants. One is line J and one is line K. So again, line J and K are secants because they touch the circle in 2 points. 1, 2, and 1, 2. Last class we talked about tangents. Tangents only touch a circle in one spot. So there's a big difference between a secant and a tangent. If two secants intersect inside a circle, then the angle is half the sum of the two arcs formed by the angle and its vertical angle. So the angle we're looking for, or they're talking about in this situation, is angle 1 here. To find angle 1, it equals 1/2 the sum of arc AB plus arc CD. That's essentially what it's saying. All right. Theorem 1013 says if a secant and a tangent intersect at the point of tangency, then the angle is half of the arc. So the angle, again, we're referring to is angle 1, which is located right here. And it's formed by again, the secant, which is AB, and the tangent line, which doesn't really have a name. So to find the measure of the angle, it's equal to half of arc AB, according to this illustration. So notice AB is being formed by angle 1, essentially. So keep that in mind when coming to find out the measurements. You're going to use the intersected arcs to help you find those angle measures. And lastly, theorem 1014 says if two secants, a secant and a tangent, or two tangents intersect outside the circle, then the angle is half the difference of the two arcs. So there's three different scenarios that could occur, but they will all have the same formula, essentially, is what's going on. So on our first picture, you see two secants. The first one has secant AD and secant AE. So this is a two secant scenario. Again, it's a secant because it hits the circle in two places. The third situation is a secant and a tangent. So secant and tangent. And then the third situation, I think I said third earlier, I'm sorry, I should have said second. The third situation is two tangents. But again, at the end of the day, the formula will be the same for all. So using the first scenario, if I'm looking for angle measure ABC or BAC, it'll equal 1/2 the difference of the measure of DE minus the measure of BC. This is for scenario 1. In scenario 2, it would be the measure of angle BAC will equal 1/2 the measure of DC minus BC. And then for the third situation, we're still looking for angle BAC. It's outside the circle, and you're going to take the measure of arc BDC minus the measure of arc BC. But essentially, it's outside of the circle, so you're going to find the difference. If it's inside the circle, you're going to find the sum. And if it's on the circle, you just take half. So what I just said can be summarized right here. It depends on where the angle is located. So again, if it's inside the circle, which again, if you want to refer back to the theorem, it's 10/12. To find the angle, it's arc plus arc divided by 2. So on this problem, it would be 142 plus 85. Sorry, that's supposed to be 85 divided by 2. If the angle is located outside of the circle, it's going to be arc minus arc. So in this scenario, it would be 126 minus 28 divided by 2. And the last scenario, if the angle is on the circle, you're going to take the arc and divide it by 2. So the arc in this scenario is 216 divided by 2. And that summary is probably a way better way of looking at things. So now let's practice a few problems. All right, so in example 1, we're finding x, which is located right here. It's an angle inside the circle. So since it's inside the circle, to find the measure of angle x, it's going to equal angle, arc plus arc divided by 2. So we would need to know what that arc is, which we don't have that arc. Tricky, tricky. We got to do an extra step. Okay, so we're going to first find the measure. I should have used a bigger eraser. In order to use that formula, we have to find this angle first, because that angle has the 2 arcs necessary for the formula. So first we have to find the measure of CED. So we're going to use arc plus arc divided by 2. Okay, so that means it's 143 plus 75 divided by 2. And we need our handy dandy calculator. So 1 oh my gosh, sorry. Stop adding stuff. So 109. So 109 is the measure of CD. CED and X are a linear pair. So if I take 180 minus 109, I would get X, and that would be 71 degrees. Alrighty. For number 2, X represents an arc, but we're given the angle. So we're going to use the same formula we just used, where again the angle is equal to arc plus arc divided by 2. So let's substitute in what we know. We know the angle is 110 degrees. We know one arc is x. We know another arc is 97. And we're dividing it by 2. The first thing I would do is put 110 over 1 and cross multiply. When you cross multiply, you would get x plus 97 is equal to 2 times 110, which is 220. And now you would subtract 97 from both sides, and you would get x is equal to 220. Oh my goodness, stop doing that, please. Minus 97. And 23. So x is 123. Why is my pen not cooperating now? Lovely technical difficulties right now. Alright, on example 3, if you notice the angle is on the circle, so we can find the measure of this arc, FD, because we have to use the formula angle is equal to arc divided by 2. So we need to use that to get the arc by working backwards. So the angle is 64. We don't know the arc yet, so let's call it x. And put it over 2. So I would multiply by 2 on both sides, and x is equal to 128. Alright, but that's not the arc we're looking for. We're looking for the other portion of the circle. So 360 minus 128 would be the measure of arc DEF. So that would give us 142, 112. Oh my goodness. 132. Yes, 132. Example 4, we're looking for angle L. Angle L is outside the circle, so since it's outside, that means angle is equal to arc minus arc divided by 2. I know one arc, but I know what I can find out what the other one is because I know it would be 360 minus 102, and that is 158. So this arc is 158. Good. So 158 minus 102 divided by 2. And it's 28 degrees. And lastly, example 5, we're looking for arc CD, which is highlighted in red for us. We're given this angle, which is outside the circle, so we're going to use the same formula we just used. Angle is equal to arc minus arc divided by 2. So again, we're given the angle, so we're going to work backwards to find the arc. So we're going to put 56 here. One of the arcs is, or the larger arc, we don't know, so it's going to be x. And we do know the smaller one, so we're going to put 95 here, divided by 2. So again, put that over 1 and cross multiply. You would get x minus 95 is equal to 2 times 56, which is 130. No, 112. And so add 95 to both sides, you would get 70207. And this concludes your notes for today.